Welcome to example number 8. We're asked here to determine the magnitude and the direction of the magnetic force acting on a wire in different cases. Now let's recall two things. We know that a wire that carries current, and this was shown as a demonstration in class, hopefully, can be deflected when current is flowing through it and it's within a magnetic field. It can be deflected to the left or to the right in various directions. The magnitude of that force that acts on the current carrying wire is given by this formula, and I derived this in class. It's equal to the current I times the length of the wire times the strength of the magnetic field times the angle between the direction of the current and the magnetic field. We utilize the right-hand rule. You can see up here where my fingers point in the direction of the field lines. My palm is pointing in the direction of the force, and my thumb is pointing in the direction of the current. So here's another picture you can see from the notes. So let's get on to example number 8 now. In each of these examples, you'll see that the angles are all either perpendicular or 0 or 180 degrees. Anyway, let's continue on here. Let's calculate the magnitude of the force. To calculate the magnitude of the force, we could use the formula FB equals I times L times B times sine of the angle between the current direction and the magnetic field. So if we substitute in here, we're going to have the current of 0.5 amps in each of the cases. The length of the wire is given as 3 meters. The magnetic field strength is 0.2 teslas. And the angle, often in many of these examples, is 90 degrees. So let's go ahead and calculate what that magnetic force would be. And that works out to be 0.3 newtons. Now that we know the magnitude of the force in either cases, let's take a look at how we could figure out the direction of the force on the wire. So I'm going to show you using my hand here. Okay, if you can look at the bottom right of your screen, you should see a little video up there, and we can see that the B field here is pointing to the right of your screen. The current is going up. So remember that your fingers point in the direction of the field, your thumb is in the direction of the current, and my palm will be facing into the screen. So the direction of the force in this case is into the screen. So FB, and you could say into a page or a screen depending on what you're writing on. Okay, moving on to part B now. We have in this example a dot. Now that dot means that the current is coming out towards you. The field is going upwards. So we put our thumb towards you. All right, the field line's going straight up, something like this, and your palm will be facing to the left of the screen. So the direction of the magnetic force in this case is to the left. Moving on to part C now. We have the current going to the left and the magnetic field also going to the left. And if you recall here, I could just calculate the magnetic field. It will be equal to I, L, B, but the sine of 0 degrees. And sine of 0 degrees is 0. There will be no magnetic force. If you recall, there will be no magnetic force if the current and the field are parallel or anti-parallel. Let's go on to part D. If you look at part D, the magnetic field is going into the board or into the screen, and the current is also going in too. So the angle is 0 degrees, so here our magnetic force will be 0 as well. Okay, now we look at E part, and we have a current that is going to the left and a field that is coming out towards you. So we want to orient our thumb to the left of your screen and our fingers pointing towards you. So if our thumb points to the left and our fingers are out towards you, then our palm will be facing upwards. So FB is going to be that direction, upwards towards the top of your screen.